On the playlist Basic Machine Learning, and in today's video we are going to learn about how can we handle the missing values. Like we all know how important is data to build a good machine learning model. We know about GIGO, garbage in garbage out. So the quality of data we feed to our model, the better will be the output, the better will be the prediction model. However, in real world it's a real hustle to get perfect data. Data is messy with lots of missing value data points. So as a machine learning engineer, our job, your job is to handle those missing values and extract good insights from by handling those missing values. In today's video we are going to learn how exactly we are going to learn that. We are going to learn about tools, libraries and different functions that can handle those missing values. And I have opened Jupyter Notebook files, and I have downloaded a Titanic dataset CSV file. You can get it from Kaggle, and I have stored it in the same folder where the Jupyter Notebook is. And firstly we are going to import libraries. So like I mentioned in the earlier videos, pandas is used for data pre-processing, numpy is for mathematical calculation, and matplotlib is for the plotting of the plotting of the graphs. We are going to learn about that, and c1 is more advanced for matplotlib. And firstly we are going to read data. Let's run this cell, and we are going to read data by using pandas, that is pd.read csv, and train csv dataset that I have downloaded. And this shows the compact for version of the data frame, pandas data frame. So we can get the basic intuition that we have 891 rows with 12 columns. So 1 2 3 4 5 6 7 8 9 10 11 12. So we can see that here is NaN, here is NaN, here is NaN, here is NaN. These are called null values, not number values. So let's see the basic information of our dataset. That is, like I mentioned here, we have 891 rows. So passenger ID has 891 rows. If you look closely, then in the age section, age column, we have 714 data only. So that means age column, this column, where is the age column? This column has not a number or null values. You can see one of the null values here. And parts is 891, and cabin, in the cabin there are only 204 data points. Similarly in the embark section there is 889 data points. So in the embark section there are only two data rows where data is missing. So if we use df.isNull.sum, then we can know how many null values are present in each column. So I have said 809. If we have non-null values 891 counts, then we can get say that there is 0 null values. In the age section, age column, there are 177 null values. In the cabin there are 687 null values, and embark there is only 2. So let's see what are the unique values present in embark section. So we can get a clear idea that embark is an object data type, that means it is categorical. And age is a float 64, that means it is a numerical value, and a cabin is also numerical value. So if you get if we do unique, what are the unique values present in embark column? We can get S, C, Q and NaN. This is the null values. We have to remove this. So handling null values, how can we? So first step is to drop the entire column. If you look closely in the cabin, there are 687 data points which has null value out of 891. So that means it has only 204 data points and 687 null data points. So it's better to remove these kinds of rows, this kind of columns. To drop the column, we did df.drop cabin and this is the axis, and in place is equal to true to replace the df with updated dropped df. And now if we see df.info, we can see that there is no cabin column, and like this. And again, how can we remove the this is the way to drop the entire column. And if you have to drop the null rows only, then we can simply do df dot drop na, and we can get the idea that 712 data points has, after dropping the cabin column, we can get 774 rows that has all the valid data points. But we are not going to drop all the 177 rows of the age we have. So how can we replace that 177 rows of age and two rows of embark? So for that we can impute this with mean, median, and mode. Sorry, I have written here mode, and this is mode. So for categorical value, firstly we are going to look how can we replace the null values with categorical value for categorical variable. And I have done df.info. Like I mentioned already, embark is a object that is categorical value. So I what I did is I I use df embark that mode to know the mode value, that is highest, the most frequently used data points in the in the embark column. And I replace that, I fill any value that is not a number value with mode. And if I did this, what I get is df dot is null, so embark is 0. And for the numerical value we can use mean or median, and the choice between mean and median depends on the distribution of data. Let's see how is our data. So we have first know the how is the distribution of our data. It is either it is binomial normal distribution, or it is slightly skewed towards one in right or left. It depends on the data distribution, and we can, if the data is slightly skewed towards right or left, we can use median. And if it's normal distribution, then it's okay to go with mean value, mean of the entire data column. So let's plot this, and from this we can get that it is not perfect normal distribution, however it is not skewed towards one end either. So, and for better understanding, let's calculate mean and median of the age column. And if we see that 29.699 and 28.0, say 28.0 is the median and 29.69 is the mean value of the age column. So it lies around here. So this is this. So there is not much difference between mean and median from 0 to 80 data range data value. So it's look like normal distribution. However, I like to say that it is not a perfect normal distribution, but it looks like normal distribution. It is just skewed towards either one end, so it's better to go with the mean. And I impute df is null values with I feel nearly value with mean of the age. And if I do this, it has fill any value with mean that I've just calculated above, and df.info. We can get that 891 non-null values in every column. And if we do is null.sum, we can get that all the columns have 0 null values. So like this we have been able to handle the missing values. And other popular techniques include last observation carried forward, LOCF method. I will try my best to make a video on this again in the next video, in upcoming videos, using algorithm that support missing values, like KNN doesn't care about, NavBase doesn't care about the missing values. And we can also use classification or regression to predict the missing values. So I have done a project, or there is a Kaggle competition in the playground series in S3 season 3 episode 15 of the Kaggle playground series where you have to just do prediction of missing values. You can also try about that. I have done that, and I'll try my best to upload that also, how I pursued that competition. And this is the way how can we handle the missing values. Thank you. See you in the next